going to study the force between two parallel currents. Here we can consider two conductors 1 and 2 separated by distance d. Okay, let I1 and I2 be the parallel currents flowing through the two conductors. Here I1 and I2 are the current flowing through the two conductors in the same direction. Let L be the length of the conductor. Now, what is the magnetic field at this point due to the current I1? So, we know that around any current carrying conductor there is a magnetic field. So, what is the magnetic field at this point due to this current carrying conductor? We know magnetic field at a point due to a straight conductor is given by the formula B equal to mu 0 I divided by 2 pi R. Okay, from Ampere's circuit law first application. So, we know magnetic field, if we consider the first conductor. Okay, so magnetic field at distance d from the conductor 1 is, we know magnetic field is given by the formula B equal to mu 0 I divided by 2 pi R. Here we can write B equal to mu 0 I1 because we have taken the magnetic field at the point due to the first conductor I1. I1 is the current flowing through the first conductor. So, mu 0 I1 divided by, we have to find out magnetic field at this point, distance d from the first conductor. Therefore, it is given by mu 0 I1 divided by 2 pi d. Okay. Now, what is the direction of the magnetic field? This magnetic field can be represented as B1 due to the current I1. No? So, the magnetic field can be represented as B1. And what is the direction of magnetic field? Magnetic field at this point due to the first conductor is, direction is given by right hand thumb rule. So, current is in the upward direction, direction of magnetic field is into the plane of the paper. So, direction of magnetic field can be represented as into. This represents the direction of magnetic field B1. Okay. Now, we can see that the second conductor, current flowing through the second conductor is I2. This second conductor of length L is placed in which magnetic field? Placed in the magnetic field B1. Is it clear? So, the conductor, second conductor carrying current I2 having length L is placed in the magnetic field B1 which is provided by the first conductor. Now, we can say that second conductor, conductor 2 is placed in the magnetic field B1, isn't it? And hence it experiences a force. Whenever a conductor, current carrying conductor of length is placed in external magnetic field, it experiences a force. Therefore, force experienced by conductor 2 is, what is the force experienced by the conductor 2? What is the formula for force? We know force is given by F equal to ILB sin theta. Okay, so the force experienced by the second conductor due to the magnetic field provided by the first one is given by F equal to, we have the formula F equal to ILB sin theta. This is the general formula. Here what is I2? Okay, second conductor is placed in which magnetic field? B1. So, this is the force experienced by the second conductor due to the magnetic field provided by the first. Therefore, this force is F21. F21 is the force experienced on the second conductor due to the magnetic field provided by the first. Okay. Now, what is theta? Theta is the angle between current and magnetic field or length and magnetic field. Usually, it is the theta is the angle between length and magnetic field. What is the direction of length? In the direction of current. Okay, so here what is the direction theta? Theta means the angle between length and magnetic field. Both are perpendicular, no? Therefore, theta is equal to 90 degree. Therefore, we can write F21 equal to I2 LB1 since theta is equal to 90 degree. Right, is equal to I2 LB1. What is the value of B1? Mu 0 I1 divided by 2 pi d. So, substituting we can write, already we have substituted, and we can write mu 0 by 2 pi into I1 I2 L divided by D. So the formula for force acting on the second conductor due to the magnetic field provided by the first one is F21 is equal to mu 0 I1 I2 L divided by 2 pi D. Okay children, now what is the direction of this force? The direction of force is given by Fleming's left hand rule, isn't it? So force acting on the second conductor due to the magnetic field provided by the first is F21 is equal to mu 0 I1 I2 L divided by 2 pi D. And the direction of force is given by Fleming's left hand rule. That is, magnetic field is into the plane of the paper. Current is in which direction? Upward direction. So the direction of force is towards left. Here like this, current magnetic field is into the plane, current is in the upward direction, so direction of force is given by thumb, isn't it? So the direction of force is towards left. So the direction of force is towards left. This force F21 is towards left. Clear? Now, magnetic field at distance D due to the second conductor. Okay, what is in there? This is the next one. Magnetic field at distance D due to conductor 2 is magnetic field at this distance. Here magnetic field at the distance D due to the second conductor is, we know what is the formula for magnetic field. Magnetic field due to the straight conductor is B equal to mu 0 I divided by 2 pi D. Isn't it? Here magnetic field due to the second conductor, therefore we can write B2. Due to second current I2, therefore I2. Okay, so B2 equal to mu 0 I2 divided by 2 pi D. So this is the magnetic field at this point due to the second conductor carrying current I2. Okay, and what is the direction of that magnetic field? That is also given by right hand thumb rule, isn't it? So current is in the upward direction. Due to this current, there is a magnetic field here. So current is in the upward direction. So the direction of magnetic field is given by right hand thumb rule. Here current is upward and the direction of magnetic field here is outward. Like this. Current is in the upward direction. Here the direction of magnetic field is outward. So it is represented by dot, which is B2. Okay. Again we can say the conductor 1 is placed in which magnetic field? B2. This conductor 1 carrying current I1 is placed in which magnetic field? B2. Now we can say conductor 1 is placed in the magnetic field B2. Okay, so conductor 1 is placed in the magnetic field B2. Here also it experiences a force. Therefore, force experienced by conductor 1 is, we know the general formula F equal to I L B sin theta, isn't it? So here first conductor is placed, no? Therefore I1. Magnetic field is provided by the second, isn't it? Therefore B2. Clear? Here the force is acting on which conductor? Acting on the first conductor. Therefore F12. So what is F12? Force acting on the first conductor due to the magnetic field provided by the second. That is F12. Here also theta means the angle between length and magnetic field. So length and magnetic field are perpendicular. Therefore theta is 90 degree. Therefore F12 equal to I1L B2 since theta is equal to 90 degree. Now we can substitute F12 equal to I1L B2. What is the value of B2? Mu 0 I2 divided by 2 pi D. Or F12 can be written as mu 0 I1 I2 L divided by 2 pi D. So force acting on the first conductor due to the second conductor and force acting on the second conductor due to the first conductor. F21 and F12 are equal. Magnitude wise both are equal. Okay children. Now what is the direction of that F12? That is also given by Fleming's left hand rule. Here what is the direction of force F12? That means force acting on the first conductor. Here magnetic field is outward. Okay. Current is in which direction? Current is in upward direction. So direction of force is, here magnetic field is outward. Current is in the upward direction. No? So what is the direction of force? Force is towards right. Okay. So from Fleming's left hand rule, the direction of force is towards right, F21. So magnitude wise both are equal, but direction wise they are opposite. Therefore we can write vector F12 and vector F21 are equal and opposite. Okay, magnitude wise both are equal, but direction wise from Fleming's left hand rule both are opposite direction. Therefore we can write vector F12 is equal to vector F21. And what is this law called? This is Newton's third law. Isn't it? Okay, F12 and F21 are equal and opposite. This is Newton's third law. Hence we can say that Ampere's circuital law. This formula is obtained from Ampere's circuital law. Then Biot-Savart's law, Ampere's circuital law, Biot-Savart's law, and this is called Lorentz force. Okay, this is another form of the Lorentz force. So Ampere's circuital law, Biot-Savart's law and Lorentz force are in accordance with Newton's third law. Okay children. Thus Ampere's circuital law, Biot-Savart's law and Lorentz force are in accordance with Newton's third law. That is the importance of or significance of this equation. Hence we can say that the parallel currents always attract. Okay, here both the currents are in the same direction, parallel currents, and what is the direction of force? They are attracting towards each other. So we can say that parallel currents always attract. What happens if currents are anti-parallel? That means one current is in the upward direction and another in the downward direction. So currents are in the opposite direction. Okay. Now what is the direction of magnetic field? Due to current I1, the direction of magnetic field is into the plane. Okay, into the plane. So that is B1. There is no change in formula for B1. Formula, everything same as that of the first case. Now we can say that this conductor I2 conductor, so this is the first conductor, this is the second one. The conductor 2 having length L, carrying current I2 is placed in which magnetic field? B1. So what will be the force experience? Force is here, current is, magnetic field is into, current is in the downward direction. No? So what is the direction of force? Force is towards right. So the direction of force is towards right. So that is the only change. Force acting on the second conductor due to the magnetic field provided by the first is towards right. Right. Now due to this I2, what is the direction of magnetic field? Here direction of current is downward. The direction of magnetic field is at this point the direction of magnetic field is also into the plane. Clear? So this is B2. Magnetic field at the point due to the second conductor carrying current I2 is magnetic field is B2. Now we can say that the first conductor carrying current I1 is placed in which magnetic field? B2. Here also a force experienced. The direction of force is here, magnetic field is into, okay, magnetic field is into the plane, current is in the upward direction, so the thumb towards left. So the direction of force acting on the first conductor due to the magnetic field B2 is F12 is towards left. So formula and other derivations are same as the first one, but the direction of force, see the direction of force, F21 is towards right, F12 is towards left. That means here also the magnitude wise both are equal, direction wise opposite, and here the parallel, anti-parallel currents always repel each other. In the first case we have seen parallel currents always attract. Similarly, anti-parallel current always repels. Okay. Hence we can say parallel currents attract and anti-parallel currents repel. Now we can see the physical significance of this formula. We have the magnitude of force per unit length is given by F12 by L or F21 by L equal to mu 0 I1 I2 divided by 2 pi d. Okay. Let I1 is equal to I2 is equal to 1 ampere. And the distance, separation between the two conductors, let it be 1 meter. Now, what is the force by length F12 by L or F21 by L? Both are equal. Is equal to, we can substitute mu 0. I1 and I2 is equal to 1 ampere. Okay, divided by 2p. 2 pi d is equal to 1 meter. Okay, and we know what is the value of mu 0, 4 pi into 10 raised to minus 7 divided by 2 pi. So, it is equal to 2 into 10 raised to minus 7, unit is Newton per meter. Okay. So, the importance of this formula is we can define what is 1 ampere. If two conductors are there carrying 1 ampere current each and the separation between them is 1 meter, what will be the force acting per unit length? That will be 2 into 10 raised to minus 7 Newton per meter. Hence, 1 ampere is defined as 1 ampere is the value of that steady current which, when maintained in each of the two long, straight, parallel conductors of negligible cross section and placed 1 meter apart in vacuum, would produce on each of these conductors a force equal to 2 into 10 raised to minus 7 Newton per meter of length. So, this is the definition of 1 ampere. So, we know 1 ampere is the fundamental unit. We know in SI there are 7 fundamental units and 1 unit is ampere. Okay, 1 fundamental unit is ampere, and the definition of ampere is defined from this important formula. Okay, so that is the physical significance of this formula. That means the force between two conductors.